Hey folks, welcome back. In this video we're going to go over 3 worked examples to show you how to do problems involving projectile motion. Now if you haven't already done so, check out my previous theory videos covering the horizontal and vertical motion of a projectile as well as time of flight of a projectile, as by watching these videos you'll be able to understand what we do in this one. So let's get started. Question 1 says a ball is kicked horizontally from a cliff and has a vertical velocity of 29.4 meters per second when it lands in the sea. So you can see from the picture here, we've got our typical projectile motion of the curved trajectory, and the ball's at a final vertical velocity of 29.4 meters per second just before it hits the water. Part A says to calculate the time taken for the ball to reach the sea. Well, what we need to do for any projectile problem, remember, is to treat the horizontal and vertical motion of the ball separately. And in this case, we need to use the vertical motion to find the time, since there's not enough horizontal data. So you'll see we're not given the horizontal velocity, we're also not given the horizontal distance travelled, so we don't have enough information to use the horizontal data. So that means we must use vertical data. So writing down what we know from the question, we're trying to find the time t. We know that the initial vertical velocity u is always going to be 0 meters per second for a projectile, the final vertical velocity v is 29.4 meters per second, and the vertical acceleration a is always going to be 9.8 meters per second squared for a projectile. So writing down our equation for the vertical motion of a projectile, we have the acceleration equation, a equals v minus u over t. Substituting in the numbers gives us 9.8 equals 29.4 minus 0 divided by t, and then we can multiply both sides by t to get rid of it from the denominator over here, and that would then give us 9.8t is equal to 29.4, and we can then divide both sides by 9.8 to get t on its own, and if you do that in your calculator you should get an answer of t equals 3 seconds. Part B says if the ball is kicked horizontally with a speed of 15 meters per second, how far away from the cliff does it land in the sea? Well, this time we have a horizontal speed value of 15 meters per second, and we actually have a horizontal time as well, because remember, the time to travel horizontally for a projectile is the same as the time for it to travel vertically, 3 seconds. So we have a time and the speed, so we can use the horizontal data this time, and we're trying to find the distance d. We know the horizontal speed v is constant at 15 meters per second, and the time t is 3 seconds. So writing down the equation for the horizontal motion of a projectile, we have distance equals speed times time, d equals vt. Substituting in the numbers gives 15 times 3, and you can do that in your head to get an answer of 45 meters. Question 2 says an angry bird flying horizontally at 2.8 meters per second drops a stone from its beak. The stone hits the ground after travelling a horizontal distance of 12 meters. Part A says to sketch a diagram of the situation. Well, let's start with our angry bird here, and let's say it's moving this way with a horizontal speed of 2.8 meters per second, and the stone that's dropped from the beak will travel this curved trajectory until it hits the ground, and we can say that's going to travel a horizontal distance d, which we know is 12 meters. And just like we did in question 1, we're going to treat the horizontal and vertical motion of the stone separately. Part B says how long does it take for the stone to hit the ground? Well, this time we want to use the horizontal motion to find the time, since there is not enough vertical data. So using the horizontal data, we're trying to find the time. We know that horizontal distance d is 12 meters and the horizontal velocity v is 2.8 meters per second. So writing down our equation for the horizontal motion of a projectile, we have d equals vt. Rearranging for the time t, we divide both sides by v to get t equals d over v. Substituting in the numbers gives 12 divided by 2.8, and putting that into your calculator should give you an answer of 4.3 seconds. Lastly, part C says calculate the vertical velocity of the stone as it hits the ground. Well, this time we're thinking about vertical velocity, so we want to use the vertical data, and we're trying to find the final vertical velocity v. Remember, the initial vertical velocity u for a projectile is always going to be 0 meters per second. The vertical acceleration is always going to be 9.8 meters per second squared for a projectile, and the time t is 4.3 seconds, which we just calculated in part B. So writing down our equation for the vertical motion of a projectile, we have a equals v minus u over t. Substituting in the numbers gives 9.8 equals v minus 0 over 4.3. Multiplying both sides by 4.3 gives us v equals 9.8 times 4.3, and putting that into your calculator you should get an answer of v equals 42 meters per second downwards. Now notice I've included a direction here because we were asked for velocity, and velocity is a vector quantity. Lastly, question 3 says a ball rolls off a table with a horizontal velocity of 2 meters per second to the right and hits the ground 0.6 seconds later. Part A says to sketch a diagram of the situation. Well, here's our table and here's the ball, and it's moving to the right with a horizontal velocity of 2 meters per second. The ball itself is going to travel this curved trajectory until it hits the ground, and we can say it's going to travel a horizontal distance d and a vertical height h. And just like we did in questions 1 and 2, we're going to treat the horizontal and vertical motion of the ball separately. Part B says to calculate the range of the ball. Well, if we look back at the picture, the range is another name for the horizontal distance travelled, so that is labelled d on our diagram. And you'll notice we're given horizontal velocity and a time in the question, so we can simply just use horizontal data here. So we're trying to find horizontal distance d. We know the horizontal velocity v is 2 meters per second and the time t is 0.6 seconds. So writing down our equation for the horizontal motion of a projectile, we have d equals vt. Substituting in the numbers gives us 2 times 0.6, which simply gives us 1.2 meters. Part C then says to sketch a velocity time graph for the horizontal motion of the ball. Include numerical values on both axes. Well, let's draw our axes and then our labels. So we've got v in meters per second and time in seconds, and let's include some numerical values there. So we've got the origin 0, we've got 2 meters per second for the horizontal velocity, and we've got a time of 0.6 seconds. Now remember, a projectile has a constant horizontal velocity, so that means we need to draw a constant velocity on this graph. So to do that, remember we show a straight horizontal line at the 2 meters per second, and I'm just going to draw a wee dashed line down to the 0.6 to show you that that's the time the motion is stopping at. Part D then says to calculate the vertical velocity of the ball as it hits the ground. This time we're thinking about vertical motion, so we're going to use the vertical data, and we're trying to find the final vertical velocity v. We know the initial vertical velocity u is always going to be 0 meters per second for a projectile, and we know that vertical acceleration a is always going to be 9.8 meters per second squared for a projectile. The time we know is 0.6 seconds because the time to travel vertically is the same as the time to travel horizontally. We can then write down our equation for the vertical motion of a projectile, a equals v minus u over t. Substituting in the numbers gives us 9.8 equals v minus 0 over 0.6. Then multiplying both sides by 0.6 gives us v equals 9.8 times 0.6, and putting that into your calculator gives a final answer of v equals 5.9 meters per second downwards. Now notice how I've included a direction here because we were asked for velocity, and velocity is a vector quantity. Part E then says to sketch a velocity time graph for the vertical motion of the ball. Include numerical values on both axes. Well, here's the axes and here's our labels, so we've got v in meters per second and time in seconds. And now let's include some numerical values. So we've got 0 for the origin, we've got 5.9 meters per second for the vertical velocity, which we just found in part D, and we've got a time of 0.6 seconds again. Now this time you need to remember that a projectile has a constant vertical acceleration, so we need to show a constant acceleration for the vertical motion here, which remember is shown with a positively sloping diagonal line. So we've got this going up to 5.9 meters per second, and then I'll draw a dashed line down to 0.6 seconds just to show you that that's where the motion is ending. Lastly, part F says to calculate the height of the table. Well, if we look back at the diagram, remember this was our height h here, so we want the vertical height travelled by the ball. And the first thing to realise here is that if we have a velocity time graph, remember you can find the displacement or distance travelled by calculating the area under the graph. So if we look back at our graph of vertical velocity against time here, remember the area under this graph is going to give us the vertical distance travelled, or the vertical height, which is what we want in this case. So if we find the area under this graph, i.e. the area of this triangle, then that tells us the vertical height. So we can say that the vertical height h is equal to the area under the vertical velocity against time graph. So that is equal to a half times base times height. And then if we look at our values here, our base is 0.6 and our height is 5.9. So we can say a half times 0.6 times 5.9. So we've got a half times 0.6 times 5.9, and putting that into your calculator should give you a final answer of 1.8 meters. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.